Hello everyone. The title of this video is section 7.4 part 1 on solving rational equations. So in this video I'm going to be going over a version of your Knewton Alta assignment for section 7.4 part 1. Please understand that this version I'm doing in this video, the questions I'm going to be seeing, are not necessarily going to be the exact same questions that you see when you work on the assignment yourself. Alright, but the objectives will be the same, the types of questions will be similar, and the way you would go about doing them would also be similar. So I'm hoping that watching me go through this version of the assignment helps you in some way when you're working on the assignment on your own. Alright, and I would ask also that whenever a new question pops up in this video, pause the video and try to work on it yourself. Try to do the question yourself first before watching me do it. Because if you're just watching me do it and not doing anything, not practicing on your own, you're probably not going to learn much of anything. Alright, so here's the assignment page. You will not see the words, preview of. You'll just have the title of the assignment, the mastery bar telling you how far along you've gotten, the objectives, which looks like there are 2 objectives in this assignment, your questions, and every question should have a feedback button which you can send feedback to Knewton through. You will not see the instructor cheat button, that's just for instructors. And then you will see the more instruction button, which will provide you with extra reading material or videos to help you with whatever objective you're on. Okay, so this first question is on the objective solve rational equations. Alright, so equations that have fractions involved. Right, you see the fractions here, negative 10 over q minus 2, minus, and then 7 over q plus 4. Right. So we're asked to, solve these equations if we can. Right. Find values of the variable that will make the statement a true statement. And if there's no solution, which some of these may have no solution, you're going to enter the empty set symbol, right, that little circle with a slash through it. And if there are multiple solutions, right, use a comma to separate those. Q equals number, then a comma, then a number, another number. All right, so I'm going to write this first one out and do it on some paper for you. All right, so this is the equation we were given. And once again, we're trying to find the values of q that will make this a true statement. Alright, so solving rational equations. Alright, I'm going to put the steps I'm going to follow over on the side of the page here. Alright, the first thing I like to do is factor all the denominators completely, because then that'll make the next steps easier. Right. So factor all denominators, right, just the denominators of the fractions to start with completely, which that's already done here. Right, q minus 2 is as factored as that's going to get. Same thing with q plus 4. And then the number 1, has no denominator. But remember, if there is no denominator, technically there's a denominator of 1, which is already factored, right? You can't factor 1 any further. Okay. Next step. The next step I'm going to do just for our benefit later when we're checking our solutions to the equation. I'm going to state values of the variable that aren't allowed. That are not allowed. Meaning, makes any denominator 0. Right? Because if you're making a denominator 0, that means you're dividing by 0, which is undefined, and that's not good. So that's why I'm saying factor the denominators first, because once the denominators are factored, it'll be hopefully very easy to see what values of the variable are not allowed. So looking through this, q minus 2 is a factor in a denominator. So q can't be equal to positive 2, because that would make this denominator 0. Also, q plus 4 is a factor in a denominator. So q could not be replaced by negative 4, because it would make that denominator 0. Right, and that seems to be all for this particular question. Right. So just keep this in mind for later, right? If we go through and try solving this, and we end up with a solution of 2 or negative 4, we should know that those actually don't work, right, when we go back and check them in the original equation. Okay, next is multiply both sides of the equation by the least common denominator, or the LCD, which you have seen in previous assignments and previous videos. How to find the LCD. Right, multiply both sides of the equation by, I'm just going to abbreviate it, LCD. Right. Now, first we got to find the LCD, which is very simple here, right? There are the two factors that only appear in these denominators are q minus 2 times q plus 4. Right. And the reason why we're multiplying both sides by the LCD is to clear the denominators, right? Is to clear the fractions. Right. So yeah, so watch this, right? When you take so I'm taking the entire left side, so I'll put the entire left side in parentheses. So I'm just rewriting the entire left side. Right, and then we're multiplying this by the LCD. So I'm multiplying by, q minus 2 times q plus 4. Sorry about the clutter there. And this will be distributed. Right? Both terms, right? You're multiplying every term on both sides, and there's a difference of 2 fractions here. And then the same thing with the other side, 1 also multiplying by the LCD, q minus 2 times q plus 4. Right. Now you've seen me do something similar to this when we simplified complex fractions, right? I multiplied the numerator and denominator by the LCD, and it just cancels all the denominators. Right, watch. When you multiply the first fraction on the left side by the LCD, see how the q minus 2's would cancel? And then I'd be left with negative 10 and q plus 4. So I'll write that. Negative 10 times the quantity, q plus 4 would be left over from the LCD after the q minus 2's cancel. Then we have minus 7. Right, minus 7. Now, the next fraction, the q plus 4's would cancel, and I'd be left with minus 7 times the quantity q minus 2. And then the other side, 1 times anything is itself. That's just that's just the LCD. Q minus 2 times q plus 4. Right, so hopefully you can see that now all the denominators are gone. Right, that is the whole reason why we are multiplying by the LCD here. All right. And step 4, solve this resulting equation. Solve the resulting, it should be a polynomial equation, which you should know how to solve from previous sections. So let's do that. Now remember how to solve, how we go about in this particular text, in these assignments here. We're going to try solving this polynomial equation by factoring. So I need to get a nice simplified, a polynomial on one side and 0 on the other. So I need to multiply all this stuff out and simplify it and get everything to one side. All right. So I'm distributing the negative 10 here to the q plus 4, distributing the negative 7, don't forget the negative, right, to the q minus 2, and then over here I'm multiplying, foiling q minus 2 and q plus 4. So we have negative 10q, minus 40, minus 7q, plus 14 on the left side. And then when you multiply and combine like terms over here, you have q squared. You'd have plus 2q, right? You have plus 4q minus 2q plus 2q, and then minus 8. And the left side, if you totally simplify it, combine like terms, you'd have negative 17q, and then negative 40, plus 14 would be minus 26. And now I'm just going to take everything to the one side with the q squared on it. So that would involve adding 17q to both sides, combine the q terms, and I would be adding 26 as well. Alright, I want to take everything away from one side so that we get 0. So I've got 0 on the left side now, and then q squared plus 19q, and then 26 minus 8 is plus 18. And I don't know, you know me, you can switch the sides. I like having, you don't have to do this. I just prefer it myself. I'm just switching the sides. So this expression's on the left and 0's on the right. And then now that I have everything on one side, 0 on the other, no more parentheses, we factor this polynomial. And this would factor to q plus 18 times q plus 1. And now I have what I want when solving a polynomial equation. I have a product equal to 0. And by the 0 product property, you should remember the 0 product property. If a product is equal to 0, then one of the factors has to be 0. So either q plus 18 equals 0, or q plus 1, right, the other factor, equals 0. And we solve these, right? So either q is negative 18 or q is negative 1. So here are the possible solutions. And then of course the final step, step 4 was way up here. The final step is always check your solutions. And you always check back in the original equation. Always check back in the original equation, the way it was originally given to us. Now, remember earlier in step 2 how I stated the values that the variable couldn't be? right? Q can't be positive 2. Q can't be negative 4. Neither of these values I found, negative 18 or negative 1, is positive 2 or negative 4. So these, if you're doing everything right, these should work. But let's just for this first one, let me actually test it out. All right. So some new paper here. So one of those was, Q equals negative 18. All right, so the first fraction would be negative 10 divided by, and then negative 18 minus 2 would be negative 20. All right, next fraction, minus, and then we have 7 over negative 18 plus 4 would be negative 14. And is this equal to 1? Well, let's see. Negative 10 divided by negative 20 would reduce to positive, right? 1/2, because it's negative divided by negative. And then this is, remember, that minus is a plus. This is like plus negative 7 over negative 14, if you want to change it to that. Any subtraction can be changed to an addition problem, adding the opposite. So plus, and then same thing here. Negative 7 divided by negative 14 would reduce to positive 1/2. And 1/2 plus 1/2 is indeed 1. You get 1 equals 1. Check. This is a valid solution to this equation. All right, then the other possible solution that you, again, should check was Q equals negative 1. All right, Q equals negative 1. So the first fraction we have, negative 10 in the numerator, and then if Q were negative 1, negative 1 minus 2 would be negative 3 in the denominator. Then plus negative 7. I'll put the negative in the numerator with the 7. And then Q is negative 1. Negative 1 plus 4 is positive 3. Right? And is this equal to 1? Well, let's see. Negative 10 thirds divided by negative 10 divided by negative 3 would be positive 10 thirds. Plus, and then we have negative 7 thirds. And these are fractions with the same denominator, so I can put them together. And 10 plus negative 7 in the numerator. 10 plus negative 7 is 3, and we're getting 3 over 3 equals 1, or 1 equals 1. Check, that works. So Q equals negative 1 is also a valid solution to our original equation. Once again, though, if you're working through and you know for a fact you did everything correctly, if the values you find are not those unallowable values from step 2, they should work. Right. So back in the assignment, I'm entering the values of Q that make this equation true, and it said, put a comma between multiple values, right? One of those was negative 18, comma, the other one was negative 1. And submit. Wonderful. Okay, and then after every question, right, there's an answer explanation, whether you got it right or wrong. I'd recommend you read through the answer explanations either way. If you got it correct, glance through the answer explanations to make sure you got it correct for the right reasons and that you didn't just get lucky. Or maybe they did it in an alternate method that you could add to your toolbox and use for future problems. And if you got it wrong, definitely read the answer explanations. Try to figure out where you went wrong, why you were wrong, and try to learn from your mistakes for future problems. All right, next question. It says use rational equations to find points on the graph of a rational function. Now, remember, a rational function, a function is a set of ordered pairs where every x value corresponds to exactly one y value. Right? And you can plot those ordered pairs on a graph. right, on the XY plane. And let me show you. All right, I actually have a free online graphing calculator at desmos.com here, desmos.com. And let me show you what the graph of this function will look like. Right, so I'm going to enter this way. Remember, f of x, that's the output. F of x is the output. And on the right side is how you calculate that output with an input of x. Right, so the input variable is called x. The output is called f of x. And every pair of inputs and outputs form an ordered pair, or a point on the coordinate plane. So watch this. Right, so you go back here, right, I'll show you what the graph of this would look like. It's f of x equals, then in the numerator we have 5x plus 14, and since that has multiple terms, I'll put it in parentheses. And you see graphs popping up, as I type it, divided by, and then the denominator is 6x squared plus x minus 2. So back here in the denominator, 6x squared plus x minus 2. And here's the graph, all these red points popping up. Negative 2.8 comma 0 is a point. So if you were to plug in negative 2.8, which is negative 14/5 for x, the output, f of x, the y coordinate there, or the f coordinate if you want to call it that, would be 0. And so on, right? And all these red points that are forming this crazy graph here form, form this function, right? Make up this function. All right, but let's see what we're asked about, though. We're not asked to actually make the graph. All we're asked to do is find the domain of the function. Now, remember, for a function, remember the domain was the list of all the allowable inputs. So in this case, the input variable is x. So the domain is all the allowable values of x. What values of x I can plug in to this function here. All right, so I'm going to write this down. We'll do it on some paper. All right. So once again, this is function notation, right? And in the parentheses here is x. That's the input variable, right? The input is called x, and the output is f of x. And again, over here is how you calculate the output given an input of x. Now we're asked to find the domain, right? The domain of the function, which again is the set of all allowable inputs. All right, so what's not allowed? All right, what's not allowed to be plugged in for x is anything that makes the denominator 0. So you're going to be asking, this question: when is the denominator equal to 0? And solve this equation. So I'm really only focusing on the denominator here. Right? The numerator can be any number you want. It's the denominator that can't be 0, right? You can't divide by 0. That's an undefined operation. All right, so just check in on the denominator. 6x squared plus x minus 2. When is this equal to 0? And I'm just solving a nice little polynomial equation here. Everything's on one side, 0 on the other. Fantastic. Factor this polynomial, which, let's see, I'd have to have a 3x in one of them, a 2x in the other. I know you could have 6x and x, but again, you could do the AC method, guessing and checking. I need a plus 2 here, minus 1 here. Right. Okay. Great, and again you can check this by foiling, multiply these, you should get 6x squared plus x minus 2. And then by that zero product property, either the factor 3x plus 2 is equal to 0, or the other factor 2x minus 1 equals 0, and solving each of these, x equals negative 2/3 or x equals 1/2. And what I'm going to do is put big slashes through these equal signs because these are the values that are not allowed. I would say that the domain, and it's a set of all values of x. I can use any value of x I want. So I put x here as long as, right, so a little bar or a colon sometimes, as long as x is not negative 2/3 and not 1/2 as well. As long as neither of these things are happening, you can plug it in, right? So you can plug in any value for the input x you want except negative 2/3 or 1/2, right? And that's all they're asking for, right? See the domain here? All numbers you want, right? The domain is all real numbers. See how they're writing it here in the answer box? All real numbers except what values? And we found the values that we can't use are negative 2/3 and positive 1/2, right? Because once again, those values would make my denominator 0, and that is not good. Okay. And submit. Wonderful. Once again, please read through your answer explanations. Alright, next question. So we didn't really use the graph. Oh, now we're going back to the graph, right? So see this, right? It continues on. So same function. Right? It's the same function as earlier, 5x plus 14 in the numerator, 6x squared plus x minus 2 in the denominator. And we're asked to solve the following equation. When is f of x, right? When is the output 1? Right? When is the output equal to 1? So we're trying to find values of the input that would give me an output of 1. Right? So write this out. Alright, so same function. Now we're asked to solve f of x equals 1. Well, what was f of x? They gave us the rule for it. That's right here. So this f of x on the left side of the equation is 5 times x plus 14 in the numerator over, and then 6x squared plus x minus 2 in the denominator. And then I have equals 1 on the other side. Now you can factor the denominator like I like, but notice that this is the only denominator in this equation. So the LCD is definitely 6x squared plus x minus 2. Right? You can factor it like I said, but it's the only denominator in this equation. So, just like earlier, after finding the LCD, right, I'm multiplying both sides by the LCD, 6x squared plus x minus 2. And same thing with the right side, I'm multiplying by the LCD, 6x squared plus x minus 2. And that should, cancel the denominators, right? See, the 6 LCD cancels the denominator on the left. And all I'm left with is 5x plus 14. Equals, and then the right, 1 times anything is itself, so I just have the LCD over here, just 6x squared plus x minus 2. Right. Then polynomial equation, right? Take away 5x from both sides, take away 14 from both sides, and then you know me, I like to have all the stuff on the left, just a personal preference. So we switching sides, we have 6x squared minus 4x, and then minus 16, right, equals 0. Right? Everything on one side, 0 on the other. One thing I'm noticing is that every coefficient over here is even, so I'm going to divide everything on both sides by 2 just to make the numbers a little smaller. So now we have 3x squared minus 2x minus 8 equals 0. And we can solve this by factoring. This polynomial will factor. Right, and the factors would be, say 3 times negative 8 is negative 24. We need a positive 6. So I need plus 2 over here and a minus 4 here. Right, to give me positive 6x minus, oh, nope, the other way around. My apologies. Be minus 2 here, plus 4 there, right? That way I have minus 6x plus 4x for the minus 2x. So 3x plus 4 times x minus 2. Alright, and we're getting our possible solutions here. X equals, for the first factor to be 0, x would have to be negative 4/3. And for the second factor to be 0, x would have to be positive 2. And here are and again, you can check, go back to the original equation, the way it originally looked before I did all the writing, and check these values. But notice these values are not negative 2/3 or positive half. Remember, x cannot be replaced in this expression with negative 2/3 or positive half, but neither of these values are negative 2/3 or positive half, so they should be good as long as I know I was doing everything right. So what this is saying is when the input, when the x value is negative 4/3, the output will be 1. F of x will be 1. Also, when the input is 2, the output will be 1. Right? These are solutions to that equation, f of x equals 1. But what they're asking us to enter are these two inputs here, these two values. Right? So when is f of x equal to 1? When x is negative 4/3, or when x is positive 2. And then submit that. And I believe there's probably one more part to this. Let's see. Again, please read through your answer explanations. Alright, see, they factored it first. Whatever. Okay, and then, yes, one more part to this. So same function. Same function as in the previous two questions. We're asked to find the point on the graph, or points. See how there's two ordered pairs here? Find the point or points on the graph of at the function value f of x equals 1. Well, we just saw this, right? Going back to my paper. What this would imply, right, solving this equation, f of x equals 1, this would imply that the points, the following ordered pairs, right, input negative 4/3, comma, output 1. This point would be on the graph of our function. And, input 2. Remember, the ordered pairs always go input, comma, output. Input 2, comma, output f of x is 1. Right. So both of these points would be on the graph of our function. And let me show you that. All right, let me go back to that Desmos website, and I'll plot these points, and you'll definitely see they're on the graph of that function. Remember, I put here was the graph of the function, right? This red graph here that I put up way earlier. Now let me show you these points. Right? So in the next space under, we put the point negative 4/3, comma, 1. And look at that blue point that just popped up. See, that is on our red, that's definitely on the red graph. Definitely a point of this function. Same thing for the other point, right? We had 2 comma 1. And look at the green point that just popped up, definitely on the red graph. So both these points, are on the graph of this function we were given. And it's clear to see when we're looking at a picture like this. So yes, that's what we're asked to enter, right? Just first ordered pair, input -4/3, output in the next box after the comma 1. Then the second ordered pair, the second point we would know would be on this graph, input 2, output 1, 2 comma 1, and submit. All right, and that should be it for this function, right? When we see another question on this, it'll probably be, be another function. All right, great. So next question. Back to solving rational equations. All right. So I'll write out the equation that pops up here and work on it on some paper. And I'm going to go through the same steps I went through with the first equation, right, from the very first question from this video. Right. So we're trying to find values of s that make this a true statement. So remember, first thing I'm doing is factoring all the denominators completely, right? Since there are multiple denominators and not just the one. So the first fraction is s over, and then 2s plus 6, you can factor a 2 out, right? That'd be 2 times the quantity s plus 3. And there, that's as factored as that gets. Right, minus the second fraction, we have 2 over, and this denominator, 5s plus 5, you can factor a 5 out, times the quantity s plus 1. Equals, and then on the other side, the numerator is 5 times s squared minus 3 times s minus 7 in the numerator. And you can pull a 10 out, which is 2 times 5. Right, so I'm putting 2 times 5 down here. That's 10. Just factoring it further. And then if you pull 10 out, what would be left over would be s squared plus 4s plus 3. And s squared plus 4s plus 3 would factor to s plus 3 times s plus 1. All right, so I'm hoping now that all the denominators are factored, finding the LCD will be easy. I'm assuming, and I've done LCD in videos before. I'm assuming you know how to find the LCD. I'm not going to go in a long process to do that. Now, off to the side here, all right, I'm going to put the values that I can't replace s with. So s cannot be, and hopefully it's clear from all the factors showing up in the denominators here, that s can't be -3 or -1. It can't be either of those because you'll be dividing by 0. All right, so just keeping that in mind for the rest of the question. Right. Now, the LCD, the least common denominator, would clearly be 2 times 5, or 10. There's a factor of 2 and a factor of 5 showing up in all these, and times s plus 3 times s plus 1. All right. And I leave it to you to figure out how that was. Again, I'm assuming you know how to find the LCD of multiple denominators. And then what we're doing is we're multiplying both sides, every single term. So each fraction, right, we're multiplying. We're multiplying every single one of these terms here on both sides by the LCD. And that will clear away denominators, right? All right, so I'm going to cover stuff up here. Right, so on the left side, the first fraction, you see how the 2 and the s plus 3 would cancel from the LCD. The 2 and the s plus 3. That would leave me with s, right, in the numerator. And then from the LCD, you'd still have 5 and the quantity s plus 1. So what I'd be left with is s times 5, or 5s, times the quantity s plus 1. All right, that's from the first term. All right, then we have minus 2, minus, and then, the second fraction, the denominators would cancel. The 5 and the s plus 1 would cancel in the LCD. And if those cancel, I'm left with 2 and s plus 3. So I have the numerator 2 times s plus 3, so that'd be 4. All right, 2 times 2, and then times s plus 3. So this is the left side, after multiplying by the LCD. And the right side's even easier, because everything would cancel. All right, you see the entire denominator on the left side, on the right side, is the LCD. So everything cancels, and I'm left with just the numerator, 5s squared minus 3s minus 7. All right, so now we have a nice polynomial equation. All right, no more fractions. And I'll simplify, get everything to one side, 0 on the other, and we try factoring and all that. Right? And then, of course, check our solutions. So left side, I'll distribute this 5s here. Here I'm distributing the negative 4. So we have 5s squared. Then I'll just combine like terms right now. We have plus 5s minus 4s, so that'd be plus 1s. And then we have minus 12. Okay. Equals 5s squared minus 3s minus 7. Alright, and then I'll take everything to one side. Let's see, I'll just take everything to the left side. Look at what happens. The 5s squareds are gone. Right? You would subtract 5s squared from both sides. They'd be gone. I would add 3s to give me 4s on the left. I would add 7. Right? Negative 12 plus 7 would be negative 5. And then, I got rid of everything on the right side. Right? So what I'm left with here is 4s minus 5 equals 0. And hopefully it's obvious now that s is 5/4. So I would add 5 and then divide by 4. And don't forget to check it. All right? Check it. Now, as I was saying earlier in the first question, as long as, if you know for a fact that you did everything correctly, as long as these values you're finding aren't these unallowable values, they should work. So, 5/4, that's not negative 3 or negative 1. Alright, so 5/4, if I plugged it in for s, all the s's back in the original equation, 5/4 should be a good solution. So back on the assignment page, right, I'm entering s equals 5/4. Alright. And again, please read through answer explanations. Right, continuing on. So we have another rational equation to solve. Right? So once again, I'm going to write this out, and we'll do it on paper. Okay, so first, factoring the denominators. The first denominator is just n plus 2, right? That doesn't factor any further. Minus 3. Now 3, you could write 3 over 1 if you want, but the denominator is 1. There's no factoring of 1. And then equals, and then the other side we have 8 over, and then n squared minus 4 would factor to n minus 2 times n plus 2, right? Difference of squares. Off to the side, I'm going to put the unallowable values of n, right? N cannot be equal to 2 or negative 2. Right? But any other value should be fine. Right? So keep that in mind, right, for later. Now the LCD, again, I'm hoping is obvious, is just n squared minus 4, or n minus 2 times n plus 2. And I'm multiplying everything on both sides, every term. This fraction, this 3, both terms over there, and then this fraction over here. We are, again, multiplying by the LCD. Now, the whole reason for this is, once again, to clear away all the denominators. In this first fraction on the left side, the n plus 2's would cancel, and I would have n times the quantity n minus 2 left over. All right. Then we have minus 3 times the LCD. Nothing cancels, right? There's no denominator to cancel. So both factors of the LCD are still there. So we have minus 3 times the LCD equals, and then the other side's real easy because both factors in the denominator cancel both factors of the numerator of the LCD, and I'm left with the numerator of 8. Okay. All right. So multiplying stuff over here, distributing the n. When you multiply, n minus 2 times n plus 2, that'd be the quantity n squared minus 4. And then I would distribute the negative 3. Right, the negative 3, don't forget the minus. So we would have n squared minus 3n squared, so negative 2n squared. Then we'd have minus 2n, and then plus 12. All right, so after totally simplifying and combining like terms, on the left side you have negative 2n squared minus 2n plus 12 equals 8. And then I'm going to subtract 8. So we have negative 2n squared minus 2n, and then subtracting 8 gives me plus 4. All right, 12 minus 8 equals 4. And one thing I like here is that every coefficient is a multiple of 2. And I usually don't like a negative lead coefficient. So to make all the numbers nicer and smaller, I'm going to divide both sides by negative 2. All right, dividing both sides by negative 2. So that'll make the left side n squared plus n minus 2. And 0 divided by negative 2 is still 0. Right. Left side's nice and factorable. Right, this factors to n plus 2 times n minus 1. And by that 0 product property, right, either n plus 2 is 0 or n minus 1 is 0. So n could either be negative 2 or n could be positive 1, and check. Now, one of these is bad, and that's this one. I'm saying n equals negative 2, but wait a minute. Remember earlier we said n couldn't be negative 2. Right, if I go and check this back in the original equation, these denominators, both of them, would become 0, and you can't have denominators of 0, so this is no good. I'm going to cross it out. Alright, and they would call this an extraneous solution. Alright, it's a solution you found that really isn't a solution. It's extra. It's not working, not necessary, extraneous, superfluous, however you want to say that. But this solution's fine. And again, you could check it out back in the original equation. 1/3 minus 3 would be negative 8/3. This does work. So after all that, the only one that works is n equals 1. Now, if for some reason both of them didn't work, then I would enter the empty set symbol, which you could find down here. Go to sets, and you should be seeing the empty set symbol here, this little circle with the slash through it. That's if there's no solution. That was if nothing worked. But 1 works here, so I enter 1, hit submit, and it should be fine. Again, please read through your answer explanations. All right. Next question. So looks like we're finishing the objective, solve rational equations. So once again, I'm going to write this out, and we'll find our solutions if we can. All right, so here I'm solving for v. First thing, right, factor all the denominators. So on the left side, we have v minus 10 in the numerator. V squared minus 5v plus 4 would factor to v minus 4 times v minus 1. And we have equals, and then these denominators, v minus 1, v minus 4, those are already factored completely. All right, then off to the side, after all the denominators are factored, I'm going to state those, unallowable values of v. Right? V can't be equal to 1 or 4. Because if it were, you'd be dividing by 0 and throughout this problem, and that's bad. Right. So again, I'm going to keep that in mind for later. And I'm hoping the LCD is easy to state after everything's factored, all the denominators are factored, and that would just be v minus 1 times v minus 4 here, or v squared minus 5v plus 4, however you want to write it. And we're multiplying the only fraction on the left by the LCD, and both the terms on the right by the LCD, right? So multiply. All right, and that should do some canceling, right? Get rid of the denominators. Now the left side's nice because both will cancel, v minus 4 and v minus 1. So I'm left with the numerator v minus 10 on the left side. Then on the right side, in the first fraction, the v minus 1 would cancel, and I'd be left with 3 times v minus 4. Right? 3 times the quantity v minus 4. Then we have minus. In the second fraction, right, the v minus 4s would cancel. I'd be left with 6 times the quantity v minus 1, or minus 6 times the quantity v minus 1. Alright, so let's simplify this right side here. Distribute the 3, distribute the negative 6, not just 6. So I've got v minus 10 on the left, and then 3v minus 6v would be negative 3v. Then you have negative 12 plus 6. Right, negative 12 plus 6 would be negative 6. And I'll take everything to the right. So we'll have 4v after adding 3v. And then after adding 6, we'd have minus 4 equals 0. And then add 4, divide by 4, we get v equals 1. V equals 1 as a possible solution. That seems to be the only one. But wait a minute, right? Don't enter this yet. Earlier we said v couldn't be 1. Alright, when you check this back in the original equation, this denominator would be 0, this denominator would be 0, right? You'd have denominators of 0, and that's bad. So I'm going to cross this out. That's no good. This is another one of those extraneous solutions. Well, everything I found doesn't work. Right? Every solution I found, quote-unquote solution I found, doesn't work back in the original equation. And if that's the case, that means that this equation has no solution. Alright, and what you're going to be entering is that circle with a slash through it, right? This is called the empty set. Right, the set with nothing in it, right? That tells me there's no number that makes this statement true. There's no value that you could replace v with and make the original equation a true statement. So here's how I'm entering this. Alright, so I put my cursor there and look. It's already in the sets area. You got that circle with the slash through it, just put that in. V equals nothing. Right? There's nothing V could be replaced with to make that a true statement. Alright? And once again, please, read through the answer explanations. Now, based on how much is done in the other objective, I think I only have one more question. So this is going back to that use rational equations to find points on the graph of a rational function. Alright, so same as earlier, I'm going to go back to that desmos.com graphing calculator and I'll enter this function. So we have x plus 1. Alright, so let me clear these points out. And instead of 5x plus 14 in the numerator, it is x plus 1. Don't really need the parentheses. And then the denominator has x squared minus 2x minus 3. So in the denominator here, x squared minus 2x minus 3. Okay, look at this. And then this red graph pops up. Alright. Alright, so we see all, again, all these ordered pairs that satisfy it. Like, so if you were to put in 0 for x, right, the output, f of 0, would be negative 1/3. That's why it's in negative 0.333 and stuff like that. Okay. Well, back to the problem. Alright, so again, I'm going to write this function out. Now the first, and it's going to be, it looks like it's going to be probably the same 3 steps as before, where we state the domain. Then they're going to ask us to solve some equation, what values of x give me an output of whatever, and then state some points on the graph then. Right. So once again, we're asked to find the domain first. And what's the domain of this function? What are the allowable values of x? So once again, when is the denominator equal to 0? So I take the just the denominator, and I say, when is this equal to 0? Because I don't want that. We don't want the denominator to be 0. This is a very nice and easily factorable polynomial here. This is x minus 3 times x plus 1. And the only way this is going to be 0 is if x were 3 or negative 1. So I'm going to put big slashes through those. These are the values that x can't be. Alright, so the domain of this function is, little set braces here, all values of x, any real number I want, as long as, or such that, x is not 3 and, not negative 1. But all we're asked to enter are these values, right? What are the values that I can't plug in? See, the domain is all real numbers except positive 3 and negative 1. And submit. Okay. And read through your answer explanations. Next part. Same function, right? Same function, and we're asked to solve, this equation. When is f of x equal to 1? Right, so like earlier, what values of x, what inputs give me an output, f of x of 1? Right, so same function, and we're asked to solve this equation, right? When is f of x equal to 1? And f of x is calculated this way, right? It's x plus 1 over x squared minus 2x minus 3. And when is that equal to 1? Now, I'm hoping it's obvious that the LCD here is x squared minus 2x minus 3, or, x minus 3 times x plus 1, because it's the only denominator. So I multiply both sides by this LCD. Now I only got a little room here. Now that would cancel with this, right? the LCD is the denominator on the left side, and then LCD over here, but 1 times the LCD is just the LCD, so I have x plus 1 equals x squared minus 2x minus 3. And then I would subtract x, subtract 1, and then I'll switch the sides. So we have x squared, and then negative 2x minus x is negative 3x. Negative 3 minus 1 is negative 4. And this equals 0, and then this is factorable, right? This factors to x minus 4 times x plus 1. And this will only be true if x is 4, or if x is negative 1. And then check them. Now wait a minute, hang on. Remember earlier in the domain problem, we said for this function f of x, x can't be replaced by negative 1, because that'll make this denominator 0. So I'm going to cross this out. This is no good. This is what they call an extraneous solution. Negative 1 doesn't work. But 4 isn't one of these. 4 is in the domain, so that's fine. And you can check it if you want. So the only solution to this equation, f of x equals 1, is 4. So this is telling me that an input of 4 to this function will give me an output of 1. And if you're talking about graphs, right, that'll be the next part. This means that the point, ordered pair, input 4, comma, output f of x is 1, would be on the graph of f, right? Would be on the graph of this function that's called f here. And that's going to be the third part. All right, so going back. So here, right, what values of x give me an output of 1? Just the value 4. And that's it. Because negative 1 was extraneous. See, negative 1 is not the domain of f of x. Read the answer explanations. And then finally, now that we have this information, put what ordered pairs would have an output of 1. Find the points that have a function value of 1, an output of 1. And the only point that does, now here we have to actually enter parentheses, input 4, comma, output 1, close parentheses. That should be fine. Now look what happens. Let me go back here. This was the graph of all the ordered pairs in this function, right, that we, at least from negative 10 to 10 for x, and it looks like negative 7 to 7 or negative 6.5 to 6.5 for the outputs. Let me actually enter that ordered pair, right, 4, comma 1, and look at that purple point that just popped up. Definitely on the graph of this red, this red graph here, the graph of the function. So one way to easily tell that this ordered pair does belong to the function. All right, but I've already entered the ordered pair here, and there aren't multiple points, so I don't need a comma or anything. There's only that one point that we found that has an output of 1. Input 4, output 1. And wonderful. Okay, great. And that should be it for this version of the assignment. All right. Now, of course, like I said at the top of the video, the version I just did here isn't necessarily going to be the same version you'll see when you work on the assignment yourself, but the objectives are the same. The kinds of questions you will see will be similar. So hopefully watching me go through this, helps you in some way when you're working on the assignment on your own. And thank you very much for watching.